Let's learn geometry, Unit 4 review number 1. This video is going to go over 6, 7, 8, and 9. And the number 6, we're starting by discussing this quadrilateral PQRS. This is PQRS has diagonals PR and QS. I'll just get a sense of what that looks like. I'm going to draw, and here I'm going to go up here, and then a quick parallelogram, or I'm sorry, quadrilateral. PQRS. And there's my diagonals. This is diagonals PR and QS. It has two pairs of parallel sides, so I can say that this is parallel to the bottom. The left is parallel to the right. Now I slipped up, I said parallelogram. It says the quadrilateral could be blank. Choose all that apply. The one that fits best is the one that has the actual these terms in its definition. The definition of a parallelogram is a quadrilateral with two pairs of parallel sides. So parallelogram is definitely one of the answers. Now, depending on the notes you took, you had parallelogram, which gave way to the rectangle. Oops, and bad drawing. And the rhombus, which all led to the square at the bottom. Now remember that whatever the parallelogram has, everything it leads to has the same characteristics. So if the parallelogram has pairs of parallel sides, so does the rectangle, so does the rhombus, so does the square. All of these have everything that the parallelogram started with. So I can circle square, I can circle rhombus, I can circle rectangle. When it says it could be any of these things. We don't know if it definitely is one of those, but it could be one of those. Now the only two, if we look at trapezoid and kite, trapezoid is like this, which does have one pair of parallel sides, but these are on the left and right are definitely not parallel, so that's not going to work for trapezoid. It's got to have the two pairs. For the kite is like your diamond shape. There are no parallel sides on the kite. That's definitely not the answer. So for number 6, it's just A, B, C, and D. For number 7, given the parallelogram below, again, we're dealing with these parallelograms a lot, state all the properties of the sides and angles. And we have to be very specific with the sides. With the sides, we're naming each side with 2 letters. These capital letters help us name those sides. I'm going to start with just WX. And one thing I know is that if we draw these, remember these arrows mean parallel. WX we know is parallel to YZ. There's one fact that we know, one property about those sides. We can also list the second pair. XY is parallel to WZ on the bottom. Now that has to do with parallel sides, but one of the properties that results from all this, from having these parallel sides, is that WX happens to also be congruent to YZ. And the same thing with the other pair. XY happens to be congruent with WZ. So there's our 4 properties with the sides. Now with the angles, there's a lot of stuff going on with the angles. They give us these lowercase letters. Those are there to represent each angle. Now remember, with parallelograms, opposite angles are congruent. So I can say angle A congruent to angle C. They're opposite from one another. I can say angle B is congruent to angle D. Opposites. Now the other fact is that anything that's not opposite, any pair that are not opposite in the parallelogram are considered consecutive angles, and those are supplementary. In other words, angle A plus angle B equals 180. And this is going to go all the way around the shape. Angle B plus angle C equals 180. Angle C plus angle D equals 180. Angle D the last fact, and I filled up all 6, but there's actually one other really important one with the parallelogram, and with any quadrilateral for that matter. If we take all of those angles, A, B, C, and angle D, and add them up, and that will give us 360. So one extra one for the line. But there's all your properties for the sides and the angles. Moving on to number 8. Find the value of x that makes S parallel to t. This goes way back to parallel lines and transversals. If these are parallel, we have this kind of pair is called an alternate exterior pair. They're outside external angles, and they alternate over that transversal. When we dealt with these alternate exterior angles, we realized that they were actually congruent. So 7x minus 9 equals 6x plus 16. If I subtract 6x, I get x. Minus 9 equals 16. If I add the 9 to both sides, I get x equals 25. So the value of x that would make the lines parallel would be 25. What are the names of these angles? Alternate exterior. Number 9, the proof. Given quadrilateral math shown below is a parallelogram. Right away, remember we always start our proofs with the given information. Math is a parallelogram, given. Prove that triangle ATE is congruent to triangle HME. There is triangle ATE, at the bottom. Triangle HME, congruent. So for number 6, this last reason, since we're finishing with the congruent triangles, has to be either SAS, SSS, ASA, AAS, and in rare cases HL. Now if we look at those two triangles, ATE, there's ATE and HME. We're trying to get this pair congruent. In our second statement, all they're saying here in the second statement is that AT is parallel to MH and AM is parallel to TH. And we know that because it's a parallelogram. In other words, because the definition of parallelogram. L-O-G-R-A-M. Now they give us AT is congruent to MH. AT, MH in a parallelogram. Opposite sides are congruent. It is a theorem that has been proven in parallelograms. So we've got a pair of sides that are congruent. I put a little S for sides. 4. If lines are parallel, then alternate interior angles are congruent. Now given that we're working with this top triangle and this bottom one, when we look for alternate interior, remember we're looking for a Z pattern where we have those little crooks of the Z, those angles working. Now given that we're working with the top and the bottom, the Z's that will work, there's actually 2 of them. One goes like this, the other's backwards. Now if we look at this, kind of look ahead at statement number 5, angle AET, HEM. That's your vertical angles at E, HEM, AET, vertical angles are congruent. So we've got to use another pair of angles from the alternate interior pair in conjunction with the vertical angles. So if I look at a Z, just like regular Z, I'm going to kind of highlight, I'll draw this in, kind of a little nice and dark. There's my alternate pair. Now I got the vertical angles from this, so I've got a little A there. Now I'm looking at this angle and this angle. If we use the 3 letters like they did here, this T has to be in the middle of the name. ATM would be an appropriate name for that angle. Congruent to HMT would be a good name for that one. Now the last thing we have to decide is what reason we're using for congruent triangles. Again, I mentioned it had to be SAS, SSS, ASA, AAS, HL. If I look at what I have drawn here, it's hard to spot at first. I'm actually going to get rid of this. I'm going to put this S outside because when I write these A's and S's, I try to see the order of the letters. In this triangle, I've got angle, angle, and then the side. If I go around that triangle, AAS works for that triangle. So now I've got that proof finished.